This is a video tutorial to cover Lesson 3.7, Determinants of Matrices and Cramer's Rule. The first thing is to look at the general format for what a determinant of a matrices is. In this format, you multiply the diagonal going from left corner down to right times each other, and then put that product, and then you're going to subtract the product of going from the bottom left corner up to the right. When you subtract this product minus this product, that gives you the determinant of the matrices. In these cases, you can see denoted in green. I put these first and subtracted the products of the others, and I get this answer. Multiplying this product and then subtracting the product of those gives us this answer, and so forth. Now when you get down to matrices that have 3 columns and 3 rows, when you go to multiply, the first row is fine. You have 5 times 0 times negative 5, and so you get 0. But then when you get to the next diagonal, you run out of elements. Well, you have to have 3 elements in order for it to work. So what you end up doing is recopying the first column, 5, 4, and 1. You recopy it here, and then the second column, negative 1, 0, and negative 2, you copy here. You only need the first 2 columns in order to complete. That way you can have 3 here, 3 elements here, and 3 elements here. When you add those products, and then you're going to subtract the products of these diagonals, so you sum those. When you sum these, you get 0, and you sum these, you get negative 26. Negative 26 minus 0 is this number. You do the same thing each time. Again, I copied the first column and the second column in order to have enough elements to multiply for these 3, and then enough elements to multiply in this direction for these 3. Don't forget the minus. All of these are done in the same manner. Now let's look at area. The area of a triangle is plus or minus 1/2 the determinant of the points of the triangle. Remember, this is a determinant. It's not a matrix. When choosing your points for the determinant, it doesn't really matter which one is x1 and x2 and x3. What does matter is that your x and y values are corresponding to each other here and also here. So in this case, you could have put 3, 0 as x1. That would have been fine as long as the 3 and the 0 are together. Notice there's a column of 1s at the end that you just simply copy down. Again, because you have a 3 by 3, you need to copy the first column and you need to copy the second column so that whenever you multiply the diagonals, you have elements. You're going to multiply these diagonals. You're subtracting the first set of products minus the second set. Don't forget there's a 1/2 here. Now you choose the plus or minus so that your resulting answer is positive. So if it's a positive already, you just leave it positive. But it happens to be negative in this case. You got a negative 12 when you did this math. You would multiply it by negative so that your resulting answer is positive. You did the same thing here. I happen to choose x1, x2, x3. Again, you can choose any one as long as the coordinates are lined up. Multiplying this diagonal, and this diagonal, and then you're going to subtract the sum of this diagonal multiplication, product of this, and the product of this. Don't forget your 1/2. 1/2 of these numbers gives you 5.5. Now let's move on to Cramer's rule. Cramer's rule looks complicated, but actually it's not too bad. If you just simply do these steps, you'll be in good shape. So first you start with 2 linear equations. X's and Y's are all that's here. So let's write the coefficient matrix determinant. Well, it's just what it says. Take the coefficients, 1, negative 2, and copy them in. Negative 5 and 5, and copy those in. This is the determinant. This represents the coefficients of x, and this represents the coefficients of y. The next step is to go ahead and choose your constants matrix. Well, that's these numbers over here. They're not dependent on the variables, or not coefficients of the variables, they're just constants. So write yourself a matrix. Now Cramer's rule says the value of x is the determinant of x divided by the determinant of the coefficients. The value of y is the determinant of y divided by the determinant of the coefficients. Well, you need to determine what these numbers are in order to do this math. So that's what we're doing over here. So the determinant of the coefficients, you know how to do. We've already done that. 1 times 5 is 5. And negative 5 times negative 2 is 10. 5 minus 10 is negative 5. These were negative times a negative gives you a positive, but remember, whenever you're doing the determinant, you subtract the second product from the first. Now, what is the determinant of x? First, we're going to replace our x coefficients with your constants. The determinant of x replaces the x coefficients. This was the x coefficient, but now we're going to use the constants in its place. The y's stay the same. Negative 1 times 5 is negative 5, minus negative 3 times negative 5 is positive 15. So the determinant of x is negative 20. Okay, so look at the determinant of y. X stays the same, but we're going to replace our y values with the constants. So whatever value is here, if this is x, you're replacing the x's. If this is y, you're replacing the y's. Then do your math like you would before, and you get that. Okay, now that you've done that, it's time to actually solve for x and y. So we're going to take the determinant of x, which we said was negative 20, and then divide it by the determinant of the coefficients, which is negative 5. You will get 4. For the y value, you take the determinant of y, which is negative 5, and then divide it by the determinant of the coefficients, which is negative 5, and you get 1. So our final answer is that x is equal to 4 and y is equal to 1. Let's do another quick example. Again, you copy the coefficients, and that's our coefficient determinant matrix, and then determine what the determinant is. And 2 times negative 3 is negative 6. You subtracted a negative, that's what made this a positive. Then I write down my constants, 1 and negative 6. I'm going to put my constants in for x when I'm here. I'm going to put the constants in for y if I'm finding the determinant of y. Okay? Then I multiply like I've been doing and add them together. When I get these numbers, I substitute it into Cramer's rule. The determinant of x, which is 5, divided by the determinant of the coefficients, which is negative 1. And I get negative 5. The determinant of y, divided by the determinant of the coefficients, and I get 3. So here's my solution. Number 15 is provided for you. Now what happens if you have 3 variables? In 3 variables, you're going to do the same thing you did before, okay? But you just added a step. So here I have x's, y's, and z's. So I'm going to write the coefficient matrix. So 2, negative 1, 3. I'm simply copying that down. 2, 3, 0, because there's no y here. 2, 3, 0. 1, 1, 2. 1, 1, 2. And why is this over here? Well, remember when you're figuring out the determinant, you need to have enough elements, just like we were doing earlier. So you recopy the first row, you recopy the second column, so these are columns, and then that way when you do your multiplication, you can get these numbers. When I evaluate this, I get a 13 for my coefficient determinant. My constants matrix, I just happen to have an extra element because there's 3 equations. Now, this is the determinant of x, so which column am I going to replace? I'm going to replace the x column with my constants, just like I did before. But all the other columns are going to be fine. When I recopy the first column, I'm going to be recopying the column that's here. Now when I evaluate my determinant, just like I've been doing, I get 13. Now this is the determinant of y. So I'm going to leave x alone. I'm going to replace the y with the constants. And I'm going to leave z alone. When I recopy the two columns, I recopy the columns that are actually here. And then I'm going to do my multiplication, my multiplication, my multiplication, and subtract my multiplication and my products. And I get this number. Now that I'm at z, okay, the determinant of z, I'm going to replace the z with the constants. So my x column stays the same as the original, my y column stays the same as the original, but my z column is now going to be the constants. So now I can do my normal evaluation of the determinant and I get this value. Then I'm going to go over here and actually use Cramer's rule. So x, the value of x is the determinant of x divided by the determinant of the coefficients. So 13 divided by 13, so x is 1. The value of y is the determinant of y divided by the determinant of the coefficients. So here divided by here, and I get -1. And then z is similar. When I write my answer, I'm going to take x, y, and z and put it in a coordinate like this. So this is how I do it. Here's number 17 for your viewing pleasure. Good luck.